The next one we're going to do is probably, well, I'm not even going to say it's one of the most common. They're all really common. Grouping's not so common, but we're going to learn how to factor trinomials. Now, when you're factoring trinomials, we're going to look at the ones that are in the form of ax squared plus bx plus c. Now, a can be a number or it can be the number 1, in which case you won't see anything. Looking at how to factor, again, step number 1 is to greatest common factor, and this one has a greatest common factor of 2. So what you'll notice is that it just gets written all the way down this big, long process. Okay, so step number 1, greatest common factor. Trust me, you'll want to with these because it makes your life a lot easier. Then we'll be left with a trinomial. A trinomial means a 3-term expression. Now, what you're going to do is you're going to find a number whose product is AC. Now, A meaning the coefficient on the a squared term times C being the constant at the end. So we're looking for two numbers that multiply to give me 20. And add, or this pair that whose sum is B, so add to give me 9. So when I look at my factors of 20, I've got 1 and 20. Now, because I'm multiplying to get positive 20, they either have to be both positive or both negative. Because my middle term is positive, they're going to both be positive. So 1 and 20 would make 21. 2 and 10 would make 12, 3 doesn't go in, 4 and 5 make 9. Now, with this one, you have two choices. You can do the whole next steps, which means if you're factoring any trinomial, it doesn't matter if there's a number in front or not, you can split the middle term up into the two numbers that multiply to give you 20 and add to give you 9. That's going to be 4a and 5a. Then you're going to factor this by grouping, and then you're going to have a common factor to take out. That is how you factor any trinomial. But if the coefficient on the a squared term is a 1, the two numbers that multiply to give you 20 and add to give you 9 get to go straight into the brackets, because when you're multiplying this through, you've got a times a is a squared. So really, this is what's going to give you 9a, and this is what's going to give you 20, versus one that has a number in front, which I'll show you in a bit. So let's try these two questions first. Looking at this question, I notice that there's a 1 in front, so I don't have to do the whole decomposition method, although if you want to, you can. And again, by decomposition, I mean breaking up that middle term into the two numbers that multiply and add. What I'm going to do is I'm going to go straight to my brackets. I'm going to put an x and an x because I know that my first terms are going to multiply to give me x squared. Then I know that these two numbers are going to multiply to give me 6 and add to give me 5. So I'm going to put a plus 2 and I'm going to put a plus 3. All good. Okay, this one's done. Now, if I'd wanted to, I could have done that whole long process, but I don't have to, and you guys are in Math 60, so I'm not going to. Looking at this next one, I'm going to greatest common factor first because I can. I'm going to take a 2 out. I'm left with x squared plus xy minus 6y squared. Again, this is one of those ones where it's just an x in front, so I can put just an x in the front of my bracket. Now this one I chose because it also had a y at the end, which means you just shove a y at the end. Now we're looking for two numbers that multiply to give me -6 and add to give me +1. So this time I'm looking for two numbers that multiply that have different signs. So I've got 1 and 6, but it can either be -1 and +6 or +1 and -6. But regardless, they're going to add to give me 5, which is not 1. So I'm going to try 2 and 3. Now again, I'm trying to look for the combination that will add to give me 1. So it's going to be -2 and +3 that give me 1. So it doesn't matter which one you put in, but this is going to be my fully factored answer. Now let's move on to two examples where there's a number in front that won't greatest common factor. So if I look at this one, I cannot take the 2 out of every single term. So I'm going to go 2 times 3 is 6. I'm looking for two numbers that multiply to give me 6 and add to give me 5, which is going to be 2 and 3. Now don't write this down. But again, we can't go straight to our brackets and go x, x, 2, and 3, because if I multiply this out, I'm going to get x times x is x squared, not 2x squared, right? And I get 2 times 3 is 6, not 3. So you can't go straight to the brackets. Instead, what we're going to do is we're going to break the middle term up. So we're going to have 2x squared plus 2x plus 3x plus 3. Then we're going to factor by grouping. Out of the first group, I can pull out a 2x. I'll be left with x plus 1. Out of the second group, I can pull out a 3. I'll be left with x plus 1. I have that common binomial factor of x plus 1, and I'm left with 2x plus 3. And that guy is fully factored. All right, you can try this next one. I will give you the hint that there is a greatest common factor to start with. So if you look at these four terms, I can pull out a 4, or three terms. I can pull out a 4. I'd be left with 3x squared plus 8x plus 5. And so again, this doesn't have just an x squared in front, so I would do the whole process. Now, if anybody's out there being like, that's not how I factor, I just do it by guessing, cool, you do you. This is something where like I got nervous in high school factoring these because it just felt like this magic, like, let's just try numbers. And this just gives me like a nice straightforward process to try. So pause the video and give this one a go. So my two numbers are 5 and 3. And if you're unpausing the video and mine looks different than yours, that's okay. Our final answers might be the same. So I'm going to do plus 5x plus 3x. It doesn't matter the order you put these in, which is lovely. Okay, then we're going to factor by grouping. So out of the first group, I'm going to pull out an x only. I'm left with 3x plus 5. Now from the second group, I can't take anything. There's no greatest common factor, so I'm going to take a plus 1. I'm going to take that plus 1, I'm going to write it out front, and then I'm going to factor that binomial bracket, and I'm left with x plus 1. And that guy's fully factored. And again, if you want to check your factoring, you can multiply back through and you should end up back at the original question. If this feels confusing or I went too fast, there are so many videos on the internet on factoring trinomials. Just Google factoring trinomials. There's Khan Academy's a great site, and there's lots of other great sites as well.